Welcome. To summarize the session 5, so first we have discussed about reservation TDMA, which is basically a reservation scheme where n mini slots will be followed by n into k data slots. Each station is allotted its own mini slot and it can reserve up to k data slots. Maximum n stations can participate or n mobile users can participate. N represents the number of users and k represents the number of slots each user can reserve. So the mini slots were fixed for a specific user during which they can reserve up to k slots. If somebody reserved, then they will use the slot. The unused slots can be used by other stations in round robin fashion. So this is the working methodology of reservation TDMA. Then we have discussed MACA, multiple access collision avoidance. So the basic principle is the communication will not just start directly. Rather, before any communication, the sender should send an RTS message, which is request to send. This message will include the sender's IP address, the receiver's IP address, and the duration of the communication. And the receiver should acknowledge this by using a CTS. Again, which also includes the sender's IP address, receiver's IP address, and the duration of communication. Once the RTS and CTS packages were exchanged between the sender and the receiver, the actual communication will happen. So because of the introduction of RTS and CTS packets, this can effectively overcome the problem of hidden terminal and exposed terminal issues. So that is what we have discussed under MACA, multiple access with collision avoidance. And then we have discussed polling. So in polling, basically what we have discussed in the sense, polling can be used when one station is heard by all stations. Basically this is used with the mainframe type of computers. This is strictly centralized scheme with one master and several slave stations. The master can poll the slaves according to different schemes like round robin or random scheme. Okay. So one such scheme we have discussed where the base station will intimate to the uh, mobile station when it is ready for communication, and the mobile station uh, should send an uh, random number. The the mobile station should send a random number, and using that particular number, the using each mobile station will send its own random number, and if these random numbers are same, then there will be a collision. And using the random number, the base station will poll a particular mobile station, and it will communicate with that. Then we have discussed ISMA, any bit sense multiple access technique, where the base station will communicate with the mobile station either using a busy or an idle tone. So whenever the busy tone is listened, the mobile station will not communicate back to the base station. But once the busy tone starts, the mobile stations will start sending data to the base station. Again, whenever there is a collision, the base station will send a busy tone. So whenever there is a busy tone, the mobile stations will understand that there is a collision and they will stop transmitting. And then we have discussed CDMA in detail, how using code the medium can be shared, so that the same medium can be used with the same frequency, and you need not compete for frequency or time, and how multiple users can use the same channel at the same time by using code division multiplexing. We have discussed with some example codes, and also we have discussed some example timing diagrams in that context. And at last we have discussed spread aloha multiple access technique, which is also one form of code based technique. And here instead of sending the signal directly. When you send the signal normally, there may be a collision. So if you send the signal with high power, then it can be sent in a shorter duration. But you need high power. So this high power signal is spreaded based on some chipping sequence. So using this chipping sequence, the signal can be spread and then it can be transmitted. So we have discussed that with an example. So that is what about the medium access control MAC protocols. So, so basically this is a continuation of session 4. Here we have discussed all the remaining MAC protocols. Thank you.